Ex6C, which is all about radians. When we measure angles, we're used to measuring angles in degrees, but there's another unit of measurement, and that is radians. Basically speaking, we define a radian as being the angle swept out such that the arc length is equal to the radius. So in our unit circle, if you can imagine that we start from this position here, we sweep out an angle so that the arc length is equal to 1, that is, that it's equal to the radius. If we look at our interactive, I can start sweeping through here for an angle, and I keep on going all the way through, and just here I've got a radian of 1, so this angle swept through here has a radian of 1, and that just means that my radius here is 1, but my arc length going from the x-axis to where point P is also 1, and we describe that as being 1 radian. You can see that it's roughly equal to 57 degrees. I can continue on, and if I get a radian of 2, then you can see that I've swept out through this angle. The radius is 1, so a radian of 2 means that my arc length, so the curved section, from the x-axis to the point will be equal to 2 times the radius, i.e. 2. And of course we can just continue on. Notice what happens when I get to exactly 180 degrees. At 180 degrees, my radian measurement is 3.14. And of course you'll remember that 3.14 is equal to pi. I can continue on, and then after I've done one full revolution of the circle, you'll see, oh, very close, try and get this exactly, that I have one full revolution of the circle, 360 degrees, or 6.28 radians, which you would also recognize is 2 times pi. 2 times 3.14 gives us 6.28. So let's take a look at this. It's not just a coincidence, but remember that the circumference is given by c equals 2 pi r. In the unit circle, if r is equal to 1, then it becomes quite clear that after doing one full revolution of the circle, we would have gone through 2 pi radians. So we know that 2 pi radians, and we use little c to represent radians, so 2 pi radians is equal to 360 degrees. And then if I strip that back to being 1 radian, I can see that 1 radian is equal to 180 on pi degrees. In a similar way, I can say that 360 degrees is equal to 2 pi radians. I can strip it back to say that 1 degree is equal to pi on 180 radians. When giving angles in degrees, we should always use that little superscript 0. But with radians, if we're unclear, then use the little superscript c. Otherwise, just leave it plain and we'll assume that it's in radians. So what does that mean for us? It means that if we want to convert from degrees to radians, then all we have to do is multiply the degrees angle by pi on 180, where pi is at 3.142. On your calculator, just put in the pi button. In a similar way, if we want to go from radians to degrees, then simply take the radians angle and multiply it by 180 on pi. In mathematical methods, we'll most always certainly be using radians instead of degrees. And you can see here some of the equivalents. So as an example, if pi is equal to 180 degrees, then 180 divided by 6 gives us 30 degrees. For pi on 4, 180 divided by 4 gives us 45 degrees. 180 divided by 3 gives us 60 degrees. So just think of pi as being 180 degrees. For pi on 2, we get 180 divided by 2, we have 90 degrees. And we can go all the way around. I don't expect you to commit this to memory by any by any means, nor should you refer to this in the diagram. But as we keep on doing these kind of circular function questions, you become more familiar with how this works. Exact value triangles, so instead of using 45 degrees, we use pi on 4, so that's the radian measurement. And you can see here that sine of pi on 4 is opposite over hypotenuse, so 1 on the square root of 2. Same thing over here, pi on 3, so think of pi as being 180 degrees, 180 divided by 3, so this is the same thing as having 60 degrees, so pi on 3. If we look at taking the cosine of pi on 3, then it becomes the adjacent over the hypotenuse, so cosine of pi on 3 is equal to 1 on 2, and of course pi on 3 is the same thing as having 60 degrees. And we can go through all of those. The exact values are summarized in these two yellow tables, and you can see the relationship between the radians and also the degrees. So top left hand corner, you can see we've got ourselves pi on 6. There's no need to put this little uppercase C there or this superscript C, but you're not incorrect by doing it, but it clearly shows that we're talking about an angle measured in radians. So sine of pi on 6 is the same thing as sine of 30 degrees, opposite over hypotenuse, and gives us a half. So that's some easy reference for you. We'll now go and take a look at the solutions to the problems. Looking at problem 1, we've got two examples of angles measured in radians, and we need to convert those into degrees. So in the first instance, I've got 6.3 radians. So to make the conversion into degrees, all I need to do is take the radian angle and multiply it by 180 on pi, where pi is just that 3.142. So I literally put into my calculator 6.3 multiplied by 180 on pi, and that will give me 360.96, and that will be in degrees. In the second example, I've been given the radian angle in fractional format, so 9 pi over 10. So again, all I need to do is go 9 pi on 10, multiply that by 180 on pi, and then that will give me something that is in degrees. When I do that with my fractions, you'll see that it becomes 1620 pi over 10 pi. The pi's will cancel out. The 10 will go into that exactly 162 times and end up with 162 degrees. If you've got a calculator, this is not a big deal at all, but typically in exam 1, you will be required to convert angles like this into degrees. With problem 2, you can see we go from angles measured in degrees and we need to convert that into radians. So our technique here is to take the angle measured in degrees and multiply it by pi on 180. So it becomes 36.35 multiplied by pi on 180 and end up with 0.63 of a radian. And a little C there represents that it's in radians. 150 degrees, so same situation, same technique. 150 multiplied by pi on 180, it becomes 150 pi on 180. I look for some simplification here, so it's obvious to us that 30, in fact that 10 will go into both the upper and the bottom, so that becomes 15 pi on 18. And then I can simplify again by dividing both the top and the bottom by 3 to end up with 5 pi on 6. So 150 degrees is equal to 5 pi on 6 radians. That's as much as we need to do.